Greetings, my name is Jani Savolainen and I'm founder and CDO of SQL Governor, the software company. Today I'm going to start a series of SQL Sessions. These SQL Sessions present different aspects of a SQL Governor software, but more than that, they actually also answer different business problems that are caused by the databases in terms of monitoring and proactivity, then in terms of performance and in terms of capacity. So the first part of these sessions is about the blocking queries. And these sessions are typically around 15 to 30 minute sessions. So I hope you like it. Let's start. First of all, what is blocking? So blocking is a phenomenon that is associated with the sessions. So each SQL Server session have connectivity of a user or application to a certain SQL Server database. And it has a SP ID which identifies the current session. So now if you are thinking about distinct statements within a session, so queries, select star from product or something like that. So each of these statements altogether, they constitute a batch. And when you think about a transaction is actually an entity that encapsulates all these SQL Server statements into one logical unit that either is going to be committed or rollbacked. So it cannot be partially done, but all of those statements are done and isolated to that transaction. So now in this context, we can start to be talking about logs. So log is an element of, let's say, if we have different kinds of logs, like we have a page level logs, we have a tabular logs, we have a row logs, we have a index key logs, and so forth. So now when a query on a session within a transaction acquires a log on certain resource, let's say it's a row log, so update something where the product key equals to 160, for example. So then during this transaction, with these higher logging levels, like for example, if there's a row log, during this transaction, no other transaction on any other session can touch that data, that row, when the process or user is having this transaction in the session 1 ongoing. And what is then incompatible logging? It basically means that if another transaction, at the moment when the transaction number 1 is doing something in session 1 and is applying a row log for this product ID 160, so then when another session tries to either update or select resources from that particular row with product ID 160, it's not able to, because there is already a log from that another session. So just imagine if this session goes very long time. If it's problems with indexing or something else, or it's just like a large batch, it can take it can take so long that actually this session number 2 that is trying to get resources from the session number 1's certain row, it cannot. So it can lead into many kinds of problems, and these can be even changed. Like if there was session 1 that was blocking session 2, it can be block session 3, which blocks session 4, and it can explode. So that's why it's a very, very problematical phenomena on the business if that happens on the database level, on your business critical or hard systems in your environment. Also in more ordinary like CRM databases and so forth, because it can actually, you can lose some data and it can slow down your system so that it's not usable anymore. Okay. So what can blocking cause to your business? First of all, it can create slowness in business application, serious slowness. I have seen up to 100% CPU spikes like a long time just because of blocking. And then when the blocks are released and rewritten the code from those parts that needs to be or re-indexed, whatever, the CPU can go down from 100% to let's say 10% or 20% usage, and everything just runs smoothly after that. Then there are query timeouts and lost transactions, of course. If there is very big transactions, missing indexes, bad statistics, so forth. So the query timeouts will occur because the other resources, other sessions that are trying to acquire resources from another session, they cannot do that. So then, not from another session, but from the same resource on that another session. Yeah. So then, of course, there can be decreased SLAs due to the high hardware resource usage and CPU contention. This is also quite bad, so it can affect your availability, it can affect your even downtime, and it can affect your usability of your system in a critical way. All right, so then when blocking becomes problematical, one was this thing that I already mentioned, was this long-lasting queries, because they can cause slow other queries. So, for example, if there is a very long-lasting query, it needs to wait as long as the log is released, and then it can do its own thing and so forth. This is, of course, no-brainer. Then long-lasting queries can cause timeouts if it waits too long. There is command timeout, for example, 30 seconds or something. When that time is out and it cannot acquire the resources, it's cancelled. The query is cancelled, the data is lost. Then there are, of course, also suspended session chains. So that can be quite bad thing, very bad thing if there is a very busy OLTP system and some of the key tables, key rows are locked all the time, and then many of the transactions cannot touch that data, especially if they are related to another session and another, so forth. So it can really relay like a network of chains, network chain into a much greater level of problems there. Then there is some excessive CPU usage, such as multiple session timeouts, and then of course blocking depth, causing many sessions to operate simultaneously. This can actually cause like spikes in CPU because they are trying to operate at the same time when the logs are released and so forth. So this is also very problematical. And then different locking side effects like poor plans and so forth. Yeah. So then about the root causes for blocking. So one of them is this long-running transactions. Not a surprise, of course, that is very self-explanatory. Then there is, it can be missing indexes and bad weight stats. That is, of course, very clear if you think about a certain situation where you have a not index at all for some data column, and you're then querying the data on that table and trying to update something based on that where statement where this column is, and something equals to something, and it can scan the whole table and so forth. So it can take a long time before that log is released, and then all the other sessions are waiting for that one bad behaving query. Large updates, of course, big batches, that is something that definitely causes this. And then poor transaction design and inappropriate indexing levels are the ones that also can do this. Okay, but then about SQL Governor demo on blocking. What I'm going to show you is, first of all, how to identify a performance bottleneck from the alerts, how to investigate specific alert in weight stats plan cast correlation analysis, and then how to spot a performance bottleneck from the blocking queries. So let's hop into a SQL Governor now. Here we are. And as you can see, this is the main navigation panel. Here we have domains, and then in domains, within the domains, we have like SQL servers, instances, and the databases. And this navigational panel is all the way in different functionality like dashboard, alerts, monitoring, diagnostics, extended events telemetry, consolidation, and right sizing of the workloads, proxies, reporting and settings, and so forth. So now, now we are on dashboard, and I want to see specifically on a DB Pro domain what is happening there right now. And I can see there is some in server and instance alert activity. I would be able to view alerts from here, or then I just go to alerts and I want to overview of all the alerts for last 24 hours. And now in this specific case, I want to see just like last 12 hours, what has happened lately. Then I eliminate database and instance level alerts, and I just want to focus on the filtered server level on this DB Pro domain as it's now highlighted here. Then I'm going to navigating to source DB2, and I see their CPU usage just 1 minute ago. Frequency is very high, warning count is very high, 30 is the limit, and now it has value of 88. So very high CPU usage at the moment in this critical server, so there's a risk of CPU contention. Okay, so I would be able to, by clicking these three dots here, I'm able to open the alert, see the details of that on performance counter history, investigate the moment with weight stats and plan cast correlation analysis, see the counter history, adjust the thresholds if I want to, if there is unnecessity, for example, in these alerts, look at the CPU contention of this alert, or then see the recurrence patterns. Now I'm going to investigate the moment. When I click on that, I'm able to see the current hour here, so 15th of May, and 2 p.m. and 18 minutes over, and then until the range end would be the 1 hour up from that. So this is the last alert that I've got, but now it's just relate to workload analysis. If I would like to see what is happening on performance counters, I would be able to click on these counters, and I can see that, yeah, okay, there is really something ongoing here in this particular server, because there is lots of, for example, like a processor queue lengths are very high here, and also the CPU usage is having some spikes here. So yeah, but now I'm going to workload analysis, and in this workload analysis here, I'm able to see the weight stats at the moment, and this brush here, I can narrow it down to details when it's been more busier. I want to see what these bumps in the weight stats are. I see that MS SQL Server instance is dominating in weights. Okay, that's interesting. How about weight categories? Aha, so in this source DB2 I have selected here, the logs are dominating. Okay, sounds interesting. I might explain some of those issues on my CPU lately. Then I'm clicking on top weights, and I can see log MIS, so in the shared log is the dominating here, 225. Okay, 225, good. Then I'm able to see here that the, okay, master, but worldwide importers on MS SQL Server instance on this specific server is having a high plan cache worker time. So it constitutes a lot of CPU time, 3.6 minutes, 3.8 minutes during that 10-minute period, quite much. And elapsed time, I can see that worldwide importers is the most waiting sessions there. So now I'm able to actually drill down to MS SQL instance, and in there the white word importers, and here now I can see that the white word importers database has the quite interesting top queries at the moment. So on PlanCache, elapsed time, like there is quite many, for example 4592. If I click on worker time, I can see 4591 and 4596 especially. 4596 is having a lot of worker time. I click on that, I see the whole procedure here. It's called test block procedure 3S. And you can see here is the how much it uses CPU, how much it uses elapsed time, executions, rows returned, physical reads, logical writes during that 10-minute time. And now I want to click on any of these. I see that these are statements. This is the first statement, it's this one. But then the third statement here, 2.7 minutes, 3.4 minutes elapsed time, 2.7 minutes CPU time, a lot of logical reads and rows returned quite a lot. So this select star from sales.invoices is the problem here that causes that CPU to really run heavily there. So now it's interesting because it's also blocked. It seems like it's blocked because it's so long elapsed time. Is it blocked? Now is the question, is this blocked? Test block procedure 3S. We want to find out. So we go here and then the blocks, and in the blocks it was 1425. We narrow the brush down to 4025 range here. And now we can see 24, 25, here 24, and then we have different block procedure. Here we can see the blocked SQL on the left hand side and the blocking SQL on the right hand side. And then what is the wait type of it, wait time, and what is the request mode. So we can see log MIS as it showed there. So all these sessions are blocking and blocked. So there is like most likely some kind of blocking chain or just multiple blocks on different areas. It seems like in this case there are like multiple blocks in different areas because the block chains doesn't seem to follow. So now if I click on this, let me see where the block procedure is. This is the 3S. It shows the wait time at this particular minute that it was 0, but the CPU time was still a lot. So when it starts to ask this test block procedure 3S, it starts to query from the customer transactions at the same time this different blocking SQL test blocking procedure 3S. So this blocking procedure is actually selecting resources from the same table with tab log X and hold log. So that is the problem. It has the heavy log here on this table while it tries to query from another table. So this is one that causes a lot of CPU pressure and also the wait time. And this actually solved our case. So we are able to eliminate that log there by changing either checking the indexes and stats, and then seeing that whether we can arrange those queries in different way, so we can fix that in easy way. So this was how to identify a blocking query easily in the SQL Governor. So yeah, that was about it, and thank you very much. And until the next session, over and out.